What's up, people? We're going to take a look today at this another LED bulb. This one happens to be a BPCEG 25/A27/LED/4. Is that for a model number? Anyway, this is one of the few bulbs that has actually failed on us here at home. And I don't know what's wrong with this one. It just sort of stopped working. Like one day it just never lit anymore. No smoke, nothing. The filaments inside, they look okay, so I don't know if one of those is the problem or what. Down in there we can see the board, or at least part of the board. Nothing looks burnt either. So I'm going to attempt to dismantle this one by removing the base down here somehow. We'll see what's inside, and maybe we can find what failed, but it's not a repair video or anything like that. We're just going to take this apart because I think the risk of damaging the glass is really high. And the screw base down here is probably going to take a little bit of a brutal persuasion to get it to come off because it's adhered to the glass. So first of all, I think we need to remove this button again like we did on the other bulb a few weeks back. Bringing it into an overhead view, let's go ahead and see if we can get a blade in there. Maybe I can get it to lift off. There's already a little bit of a gap, and there it goes. That was easy. Sure enough, we got a wire right there that's poking through. And the little button is also kind of just friction fit there with these little barbs. Now for this next part, I should probably put on some gloves or something because it's going to require trying to remove this here from the glass. And I don't think that's going to be quite as easy as that. I managed to get this base detached from the glass, but things didn't quite go exactly how I was expecting them to. If you look right here along the base, you'll see that there is a scored cut. And so what I was hoping to do is to just cut enough of the metal so that I could detach the base, leave the filaments, the LED filaments inside along with that little glass stem there. And then I could just pull this part out, detach the wires that go to the LEDs, and take a look at what's inside of this base. Unfortunately, while I was cutting it, what I used is a cutoff wheel on a Dremel. It appears to have cut through the glass, and there we go. It just came apart again. I had glued it shut so that I could show you what it did. But so it appears that I completely detached the base and the LEDs from the glass. So I think what I'm going to do now is I'm just going to break the bulb, which I could have done from the get-go if I would have known this was going to happen. But I was trying to just keep the entire bulb assembly with the LEDs completely intact. I'm going to try to do this somehow without breaking those filaments. And you can see that there's bits of glass inside there from where I was using the cutoff wheel. All right, so I'm just going to try to stick the entire thing here in a bag. Set it down. And I'm going to try to hit it just enough to break the glass, but not damage the filaments. That didn't work. Try again. There we go. Oh, no! He left the base intact. But it looks like it cracked it through right there, so I should just be able to pull this apart. This part I can just cut like that. There we go. I can just pull that away. There we go. That's what we want. If it wasn't for the fact that it's kind of dangerous like this would actually be pretty cool. Well, I'm going to have to continue removing the bottom portion here, so let's see how far I can get by just trying to peel this off. Oh, that seems to be working pretty well. Probably should have put on gloves for this too. Although there's not as much glass down here. It's just, yeah, it's just the adhesive in the metal. Peeling apart like a can of sardines. Now we can remove the base, and is that, no, it's not potted. And this is looks like it's a plastic enclosure there for all the electronics inside. Just need to peel off some more of this adhesive there. Looks like it's just stuck to that. There we go, that's separating. So there's the two wires that go up to the LED filaments. Ooh, that electrolytic there looks kind of bulgy. Nothing looks burnt. We'll get up a little closer here in a minute. But just on the first glance, nothing looks fried. I think this might actually be the same chip as the other LED we saw the other day. The circuit might actually be the same. I guess I'll find out here in a minute. So I think what I'll do is I'll take this off. I'll take these wires off. I'll see what the schematic for this is. And we'll come right back. Alrighty, so this is a schematic that I was able to come up with based on what I saw on the board. And first of all, kind of a weird thing going on here. The positive, as we see, goes out to a small inductor, and that small inductor is this one right here that kind of looks like a big green resistor. And so this side here is positive, but the big electrolytic capacitor, that it's a 15 microfarad capacitor at 160 volts, which is that one right there. We see that the negative side is connected to the positive rail coming out of the bridge rectifier, and that goes to the negative of the LED filaments. The positive here, it goes to through this diode right here, and it gets switched by this MT7886 chip that was on the board, which is not the chip that was found in the other bulb. So I was a bit incorrect about that. Now, unfortunately, I was not able to find a datasheet for this chip. However, I did find a very crappy image of one. I think that's what it is. It looks like it says MT7886 right there, or I don't know. It's kind of hard to tell. It's very, very blurry, and it's just kind of crappy. But this seems to match similar to what I was able to find. However, if we take a look here at the bridge rectifier, it looks like they drew this in incorrectly. So here we have the AC lines, but this looks like it'd be connected to what the negative side of the bridge rectifier is. And the other one appears to be connected to the positive side of the bridge rectifier. So these here would be the AC lines going out. So this really does not make sense to this application, and it looks like maybe it was an error in whoever drew it. So we've got our AC lines coming in here. This goes through a fuse, which is marked FU. But it's one of those sort of like fusible resistors, as we saw in the other one, except that this one doesn't have two, it just has the one. So that's connected here to a capacitor that's in parallel. And while this capacitor is marked to be 47 nanofarad, and it's that little one right there, it actually only measures about 40 nanofarad. So it looks like maybe it's degraded a bit, but this is on the input, so it's probably not going to do too much of anything or cause problems. And then as we see, our AC lines go in here to 2 points on the bridge rectifier. So, and then we have our negative coming down here to provide ground and all that stuff to the chip. Now, one thing you might notice here is that there doesn't seem to be any pin on here that goes directly to the positive supply. But on that other crappy schematic, we see right here, it looks like it says VCC right there. That goes to connect it to a point between a capacitor that's connected to what I'm assuming would, that would be the ground. And then it goes through a resistor up here to the positive rail. But on what I found on this board, there is nothing like that. Like we see that here, we have that resistor going to positive, and we have this capacitor here going to negative, but there's nothing connected in between. And I checked, like I can't find anything that would be connected between here and the chip. But at the same time, we see we have a capacitor here connected in parallel between the two rails, and the resistor here with this capacitor. On the other schematic, they also have a similar arrangement with a resistor and a capacitor connected to ground, and then a capacitor here just connected directly to ground. So this other resistor and capacitor doesn't seem to exist on the board that we have. So the way that I think this chip here is getting power is probably through this point right here. So we'd have, when we turn the light on, we'd have current like flowing through that in the other inductor, which is this small transformer looking thingy right here. It just has 2 pins. And so there'd be like a positive voltage at like this point, which would go through this resistor and then further get lowered a bit by this other resistor. And then we have a capacitor here between this point and ground. So I think pin 4 might be its VCC, and then it probably has some internal voltage regulation. However, this same line here looks like it's also being taken to detect the voltage and keep it regulated over on the output, because we see we've got another voltage divider here going to pin 2. So this appears to be working as like a boost converter. And the thing is that I think that the LEDs here are using a lot, like really high voltage, because I tried lighting up just a single one of those filaments with my little bench power supply, and that only goes up to 60 volts. I think it like tops out at like 61. But at that full voltage, I could barely get one of the filaments to like sort of light up, and I had to take a little video of it like in a really, really dark, because otherwise you can't see it. So here on pin number 8, we've got this 2.7 ohm resistor, and I believe that's the current sense pins. So I think what's happening here internally is that that's where the switch inside of the chip is actually getting its current from. So in here, this would be connected to, like, say, to the source of the MOSFET inside of here. And then the drain is what's switching this inductor. So it's boosting that voltage coming in, which would be like a rectified 170 volts. Well, 120 volts rectified, so we'd have like a peak of about 170 volts here. But looks like this bulb also supported dimming. So I think this chip is controlling the current going to the LEDs, and that's how it controls the brightness. But a lot of this is like speculation because like I said, I don't have a data sheet, so I have no idea what's going on inside the actual chip. And then we've got two pins on the chip there connected directly to ground. Pin number 7 and pin number 1 connect directly to ground. So one of those is ground. I don't know what the other one does. It probably sets some other mode of operation, I'm guessing. So yeah, that's what appears to be happening. It just switches this inductor to control the brightness of the LEDs. And then we have a 160 kilo ohm resistor here between the positive and the negative of the lines going to the LED. But this is connected in parallel with this capacitor. So it looks like it's just for like bleeding the charge on that capacitor. So what failed inside of this bulb? Well, it doesn't appear to be the filaments because, like I said, I was able to get those to just very dimly light up with about 60 volts. And nothing else inside of on the board or anything looked burnt. Like I already mentioned, this capacitor here that's supposed to be 47 nanofarad only measures 40 nanofarad, but it's on the input, so it really shouldn't affect anything all that much. C2, which is supposed to be 100 nanofarads, that measures about 96, so that also doesn't seem to be too problematic. C3, which is 220 nanofarad, and that's the bigger one of those metal film capacitors. That one measured about 222 nanofarad. But this one right here, this 15 microfarad electrolytic, there we go, 240.9 picofarad. So it appears that maybe this capacitor here would have been the primary problem. It dried up and maybe caused this chip to work a little too hard. Although I couldn't find any pins shorted on this chip, like I checked between the drain and like these, all the pins that go to ground. None of that was shorted. So I don't know if this chip is actually bad. However, this fusible resistor on the input, if we took a look at that, it's covered in heat shrink, but I already cut one side of it off. That's pretty toasty right there in the middle. So yeah, it's fried, and it reads fully open with the multimeter. So that's going to do it for this one. Looks like bad capacitors once again ruined a bulb that would have been otherwise completely fine, because like I said, these look like they would still operate, and if I knew what voltage they actually were, I could get them to light up, but it looks like it's something really high, which I don't have any way to set up here quickly that I could test these out. But yeah, that's going to do it for this one. Thanks, guys, for watching once again. I'll see you guys around the bench. You guys want to see a light bulb spin again?